Over the past few years, SEDS had seen a great expansion. We're this year at record numbers for our overall college chapter enrollment, and I cannot wait to see what the future will bring to the organization. It's not to say that we've grown larger through one event or one particular focus or another, but through our overall dedication as students to our shared goal. It is sometimes said that it takes a village, and that can be said exactly for students for the exploration and development of space. It takes the students among all of us to make the organization work. If I was to say one thing about overall, what I would encourage all students to do is get involved. Get involved, because without students, there is no SEDS. There is no SpaceVision. And our mission of getting to space to explore and develop the future is at risk. Get involved, because even the least effect that you've done, that you can do for anything related to SEDS, can make the greatest difference. Get involved. You make what SEDS is. Start initiatives in whatever you think is going to make the future happen. Ask for help. Only take no as a temporary setback and not a roadblock. Make it a challenge to overcome. Make the organization what you want it to be. Join us today, be a staff member, and make a difference at a national level. To the professionals joining us this evening, I still say get involved. Your help makes it so students can do so much more than they're ever able to accomplish on their own. The students of today can learn from the professionals out there, their skills, and those skills can help build a better tomorrow. Get involved, because you make the difference, not only to those right around us, but nationally. We can affect policy, the national focus of the future, and go forward to a better tomorrow. We can set the future and take us to the next frontier. I'll now turn the floor over to the conference manager for SpaceVision 2012, Mr. Andrew Gianetti.
Thank you, Dan. On behalf of all of the UB SEDS team, I'd like to welcome you to Buffalo and to SpaceVision 2012. We're excited to be your conference hosts, and if there's anything that we can do to make your experience better, please feel free to contact one of our staff. Since its modern inception 8 years ago, this conference has grown to be the premier gathering for students and young professionals seeking to become involved in the space industry. We're brought together by our common passion for space, the desire to explore further than ever dreamed possible, the drive to learn about the universe around us, and the dedication to face and overcome challenges that quite literally can be astronomical. Over the next 4 days, we hope to harness this passion and motivation and explore and define how this generation can impact our future in space. We seek to explore the theme Crossroads. With the space industry currently at a turning point, undergoing significant changes in the way we access space, we believe that the future of space exploration and development will hinge on the activities of the coming years. As we find ourselves at this crossroads, we believe that our generation will be vital to shaping the industry in our future. Through this conference, we will explore the areas of science, engineering, entrepreneurship, and policy that shape the industry and will be important to our future. We believe that our future is in space, and that it is up to us to reach higher than we ever have before. This conference will create a setting where students can build and strengthen connections with industry professionals and leaders, and learn about and discuss the topics that are relevant to our future. I would now like to take a moment to introduce our opening keynote, Dr. Robert Braun. He will be speaking about the role of NASA in the 21st century, a topic that is very, very relevant to our future. Dr. Braun is the David and Andrew Lewis Professor of Space Technology at the Georgia Institute of Technology, and previously he worked as the NASA Chief Technologist, where he worked to develop cutting-edge technologies to enable future exploration. Without further ado, Dr. Braun.
are you this evening? Thank you all for being here. I really appreciate it. It's great to see so many young people. In particular, it's great to see so many folks interested in space. What I'd like to do today is talk to you a little bit about my vision for the future. And I want to emphasize as I get started that this is really my personal vision. I am an employee of Georgia Tech at this point. I no longer work for NASA. But my views have obviously been shaped by my experiences. My experiences as a technical person, as an engineer that sent probes to Mars, and most recently as the chief technologist for NASA. I want to talk to you about the future, but I thought that to talk about the future, we should probably start at the beginning. We should probably base our discussion in the past and in the present. So I'm going to start where most people start when they talk about NASA. It was more than 50 years ago that a young president spoke to the nation and gave this nation a challenge that was not simple, a challenge for which we didn't have an answer, a challenge that was audacious. And of course, you know the challenge that I'm speaking of, the challenge of sending a human to the moon and returning him safely to the Earth within a decade. Upon hearing that challenge, thousands of young people, thousands of engineers, thousands of scientists poured out of the nation's universities and joined NASA. They accomplished the president's goal. Look at them here in some of these pictures. Look at how young they are. You may not know this, but when Neil Armstrong landed on the moon and walked around, the average age of a person in mission control was 29. Think about that for a minute. 29 years old. President Kennedy's goal was audacious. It was a grand challenge. Upon hearing that goal, engineers built some of the most powerful engines ever constructed. They built rockets more than 36 stories tall, and they sent brave heroes on a journey farther than they'd ever been, and in fact, farther than we've ever been yet, since that time. By fusing the creativity and imagination of their time into technological solutions, these engineers and scientists captured the imagination of the world. When Neil Armstrong took that one step, we all took a giant leap. And in doing so, they defined what we now call rocket science. Many of you out here probably want to be rocket scientists. If you listen to Jay Leno or David Letterman, they make little rocket scientist jokes. Well, before these folks, nobody knew what rocket science was. They truly changed the world. And in doing so, they had a lasting impact upon our national security, upon our economic security, and upon the United States' leadership, technological leadership in the world. We didn't go to the moon to explore. We didn't go to the moon just because it was in the human spirit to do so. President Kennedy sent us to the moon for a reason, and it's best described when he said, "We choose this challenge because it serves to best measure and organize our collective energies and skills." This was a challenge that was going to prove to the world what the United States could accomplish. It was bigger than any destination, right? At that time, it was part of the Cold War. It was part of the space race, if you will. And in achieving that goal, the United States won that space race. Now, I'm a little hesitant to let you all know about this, but I have a confession to make. As great as this time was, and many people call it NASA's golden age, as great as this time was, I don't remember it. I don't remember anything about it. I think that I should remember. I was alive. I feel as an aerospace engineer who was alive in this time, I rack my mind trying to remember this time, but I can't. I was 4 years old when Neil Armstrong landed on the moon. I'm told that I was sat down in front of the TV. I'm told that I watched it, but I don't remember a thing about it. And one of the things I realized when I was the chief technologist at NASA recently, traveling around the country, everywhere I went, whether it was going to a large company, a small company, a NASA center, what have you, everywhere I went in this field, There are a lot of engineers and scientists out there just like me that don't remember Apollo. They know about Apollo through what they read in the science books, in the engineering books. Of course, being students, many of you today are in that same category. But if you were to go to a NASA center today, it would be about 50-50. Those that experienced Apollo and those that know about Apollo through history books. And the reason that I'm telling you this is because as you mature, as you refine your knowledge and go into the workplace, there's going to be more and more people like me that only know about Apollo through the history books. Well, so what does that mean for aerospace engineering? What does that mean for planetary exploration? Does that mean our best days are behind us? Certainly not. This is something that I spend a lot of time thinking about. I think about what is our generation's space race, if you will. Now, I don't mean a race against another country. What I really mean by that is what's our grand challenge? What is that goal that will serve to measure and organize the best of our collective energies and skills? I live on a small farm outside of Atlanta. When I look up at the night sky, often this is what I'm thinking about. Now, as a professor at Georgia Tech, I spend a lot of time with young people. I teach a number of classes, graduate level and undergraduate level classes. And one of my favorite classes to teach is Introduction to Aerospace Engineering. It's a freshman level class at Georgia Tech. And so in this class, maybe I have 30 students in there. In this class, there'll be basically young people that are straight out of high school. They want to be aerospace engineers because they dream about aerospace engineering, but they don't quite know what aerospace engineering is yet. And in this class, we talk about aerospace engineering, but we also talk about our dreams for the future. We talk about why I became an aerospace engineer, why they became aerospace engineers. And so what I want to do now is let you in on my list of reasons for being an aerospace engineer. And I'm going to share that with you, but I don't want you to copy it. All right? I'm going to ask, actually, that you each, if you haven't already, that you each develop your own list. These are my visions of the future. And I think as aerospace engineers, or folks interested in space, we should all have visions of the future. Collectively, we'll bring those together. Now, this list here of 9 significant game-changing possibilities for our civil space program, these aren't just dreams that I think about at night. These are things that we could, if we choose to as a nation, that we could make real. Each and every one of them. I believe that in my heart. I believe that in my soul. If we dedicated our collective energies and skills, we could accomplish these things. In fact, I believe we could accomplish each and every one of them in my lifetime. So let's take a look at a couple of these and talk about why they're important. Take maybe the second one on this list that deals with predicting major storms and natural disasters. Certainly this month, that's something that we're all thinking about. But think about the tornadoes that rage through, say, Alabama or Georgia. Think about the tornadoes that go through Oklahoma. Think about the tsunami that hit Japan not too long ago, or the earthquake in Haiti. Of course, the storm that just hit New York, New Jersey. Imagine, if you will, if we had the collective ability from space to predict those major storms and natural disasters. Not months or years in advance, but 15 minutes in advance, a half hour, an hour in advance. Think about being able to move the population out of harm's way in that short amount of time. With our space capabilities, and as they advance over time, that's something I believe that is within our grasp. The technology is there. We have to keep working on it to make it better. But we're this close to being able to predict major storms and natural disasters in time to move the population out of harm's way. Take another one on this list, one of my personal favorites, which would be the search for Earth-like planets around other stars. That's a fascinating field. You know, if I were giving this talk just 5 years ago, I would say that when I look up in the night sky and I see all those stars, I know that there have to be other planets out there. There's just so many stars. There has to be another planet somewhere. But today, standing here, I can say that I know that to be a fact. It's not just my opinion. It's from missions like Kepler, Hubble Space Telescope and other missions, that we actually know that. And as our technology gets better, I believe the definition of what we call an Earth-like planet will also get more refined. Today, an Earth-like planet is something that's in the Goldilocks zone. It's close enough to its star. It's not too warm. It's not too cold. Right? It's about the right temperature. A few years from now, an Earth-like planet will be rocky. Perhaps we will know it has oceans. Perhaps we'll know it has an oxygen-rich atmosphere. As our technology improves, so will our definition of this term, Earth-like planet. That's just fascinating to me. This is something that's changing in front of our very eyes. By the time that you in the audience here are my age, and I'm not that old, but by the time that you're my age, I think that you'll be what we'll call an Earth-like planet. It will be very different, much more refined than what I call an Earth-like planet today. That's how fast this field is changing. The search for life in our solar system. Since man walked out of the cave, he probably wondered if we were alone. There are a number of places in our solar system where we believe there may be the building blocks or basic life in the subsurface of Mars, beneath the ice-encrusted world of Europa, perhaps on Titan. Our robotic explorers are getting closer and closer to detecting that life. It's something that I believe will happen in my life. If it doesn't, I'm sure it'll happen in your life. And I could go through all of these with you and talk to you about why I'm so excited about them. The point is that I am excited about these 9 things, and I believe in them. These are technical challenges that I'm thinking about when I wake up in the morning and still thinking about when I go to bed at night. And what I hope is that each of you has a technical challenge or 2, perhaps 10, just like these that you're thinking about, that you're committed to, that you want to make real in your career. Don't go into this industry and expect to be told what to do. Go into this industry and make it happen. Whatever it is that is your passion, make it happen. Let me talk a little bit more about one of the perhaps grand challenges. This is a challenge that has been in the press a lot lately. The idea of sending humans to Mars. And here I'm talking about to the Mars surface. It's something that I've worked on. In fact, straight out of college, I graduated from Penn State with my bachelor's degree. And right out of Penn State, I went to work at NASA Langley. And this was actually my first job. Hey, Bobby, go over there and figure out how to land humans on Mars. The first President Bush, President George H.W. Bush, had something called the Space Exploration Initiative going. And I was a part of that, working on that activity. It was a great first project for someone coming out of school. Let me tell you, this idea of landing people on Mars is hard. It's really hard. And I know that. I know a thing or two about landing on Mars. In fact, since the 90s, I've been involved in one way or another with all of the landers that have happened, all of the Mars missions that have landed on that planet. Starting with Mars Pathfinder. Mars Pathfinder, of course, was a new technology in itself, the first planetary rover, the first rover on another planet. Landed in a way that we had never tried before. You may remember the airbags. Some of you may think of them as beach balls, the bouncing and rolling to a stop. All of that had to be invented. That's what NASA does, right? It invents new engineering solutions to accomplish grand science goals. All of that had to be invented to land the Sojourner rover. We were so excited when we landed that rover in 1997. By the way, that rover, it's about this big. I mean, think about that. Think about what we've sent to Mars since and how far we've come since Sojourner. Of course, we've most recently landed the Mars Science Laboratory, and I'll talk to you more about that later, but they had to invent a whole new way to land on Mars to make that occur. And as great of a feat as it is to land the Mars Science Laboratory, the Curiosity rover, a rover the size of a small car, we went from something this big to a small car. As great of a feat that is, it pales into comparison to what would be required to land humans. When we land humans on Mars, we're not going to land a small car. We're going to land a 2-story house. And we're going to land that 2-story house right next to another 2-story house that was pre-positioned autonomously. They're going to land so close that we can reach out of one window and hook up, right? Because that first mission will have power, it'll have life support, it'll have rocket fuel, all the things that that second mission needs to be successful. Just to give you a feel for the scale, by the way, in this bottom image, I photoshopped in the lunar excursion module that took Neil Armstrong and others to the moon. That's a scale replica. I sized the astronauts to make sure they're about the same scale. Take a look at how big these Mars landers have to be. That lunar excursion module is by far the largest lander, human-capable lander, ever created. Very successful in the 60s. And look, even relative to that, we have a long way to go. This is quite a challenge. Now, another way to look at this challenge might be in terms of the mass required to start the mission. And I'm showing that mass here on this slide. And the mass that I'm referring to, by the way, this is the mass not here on the ground on a launch vehicle that we need to get started. This is the mass up in low Earth orbit. So we assemble all this mass in low Earth orbit. When it's all together, then we send our first missions out to Mars. Take a look at the mass requirements. I have it plotted here. It's the same mass. I have it plotted 3 different ways because it's so hard for me to fathom what 4.5 million kilograms actually is. Instead of 4.5 million kilograms, think about it this way. That's just 12 international space stations. Well, think about the Saturn V, the launch vehicle I spoke to you about earlier. The largest and most powerful launch vehicle ever created. Just 37 launches to assemble this one Mars mission. Now think about what it would take. And by the way, this is the mass required if we went with flight-proven technology. If we went with the systems that have already been flown in space, the systems that we're comfortable with, that we either flew on the space station, flew on the space shuttle, no advanced technology. This is what the mass requirements for that mission would be. Now imagine that you have to sell this in Washington. Well, Senator, we would like to send humans to Mars. We think it's the right goal for the country. All we need to do is assemble 12 international space stations en masse, and we'll be ready to go. How many of you think I can sell that in Washington? If you think I can, then you have a lot more confidence in me than you should. It only took us 10 years to assemble one international space station. 1 unit of mass. So what are we going to do about this challenge? Well, there is a solution. And that solution is to not do it the way that we've always done it in the past, but to invent new ways of approaching this business. And so here what I'm showing is that if we advance just a single technology, we can cut the number of international space stations that I need to start this mission down considerably. I can cut it down from 12 to maybe 5 or 6 international space stations. Anybody buying yet? I just need to assemble 5 or 6. I don't see any takers. Well, what if I invest in a whole range of technologies? Technologies, by the way, that report after report after report that has studied this problem since the late 60s have all said are the right technologies for us to invest in. Most of these are propulsion, propellant-related technologies because about 80% of the initial mass in my 12 space station case is propellant. So obviously anything that reduces that mass has a big impact. But what you can see here is that if we make the right technology investments, if we develop the capabilities for our future space capability in just the right way, we can get this down to 1 or 2 international space stations. I can get it to within spitting distance of what we've already achieved. And then we really have something. Then we have a way to actually accomplish this mission. We have a feasibility proof that this can be done. And that's why I'm so interested in advancing our capabilities in space. Not just in going out in space and doing missions, but in actually improving the way, in building our capabilities to improve the way that we go about accomplishing those missions. Now, I want to focus for a minute on human spaceflight. I know that if I don't, there'll be a lot of questions anyway. Because human spaceflight is something that has been in the news a great deal over these last few years. And it's something that you all must know about already, but I want to make sure that when we're talking about this over the weekend that we're all on the same page. So I'm going to start with this slide here. This slide, which, by the way, from where I'm standing, I can't read any of my slides, just so you know. so I'm counting on you to read them for me. This slide here talks about human spaceflight as it existed when I was your age or a little bit older. When I was starting at NASA, working at the Langley Research Center, all the way up through about 2003. The plan for human spaceflight was simple. The space shuttle was our workhorse. We were going to keep flying the space shuttle. We were going to build the space station. And we were going to use the space shuttle to service the space station through about 2015. And then somewhere around, before 2015, but somewhere as we approached 2015, we were going to start building a replacement vehicle for the shuttle. That was NASA's plan. That was NASA's plan for a long time. And then, of course, Columbia happened. And NASA was caught, we were all caught, flat-footed. We weren't prepared for that. President George W. Bush was the president at that time. It was a very traumatic experience for all of us across the country, certainly at NASA. But President Bush put together a team. They reviewed our current position in human spaceflight, and they set forward on what I would consider to be a very ambitious and very worthwhile plan for NASA. President Bush's that planning agency came out with two findings. The first was that the space shuttle was a risky vehicle. It was an experimental vehicle. Even though it had been flown for a number of years, it was always going to be an experimental vehicle, and we did need to phase it out. And he set the goal of phasing out the space shuttle program by the end of 2010. The second thing that he announced in 2004 was called the Vision for Space Exploration. And the Vision for Space Exploration, I will tell you, was a grand and glorious plan. It was a human and robotic partnership to go out and explore the solar system, the moon, Mars, and beyond. It was a very well thought out, very well crafted plan. NASA took that plan and started working on it right away. By the way, the Bush administration promised a very small budget increase to go along with that plan, partly for the shuttle program, but also to get that plan going. NASA's original implementation of the Vision for Space Exploration was a technology-based plan. It was a capabilities-based plan. Let's develop the capabilities that we need to become deep space explorers. But unfortunately, the budget that was promised didn't materialize. And there are a number of reasons for that. And when the budget didn't materialize, NASA's implementation plan changed. It became more and more near-term focused, and it became more and more single destination focused, until what we had was the Constellation program, which was basically an evolved capabilities sprint, if you will. It was kind of a slow sprint, but a sprint back to the moon. It was not, in my personal view, it was not equivalent to the Vision for Space Exploration that was much broader in its approach. This was the plan that was, by the way, just to give you an idea, on this slide here, I'm showing the budget. What's shown on the top curve here is the budget that was used for planning purposes during, it's called the Exploration Systems Architecture Study, which is the study that preceded the development of the Constellation program. And then the other two lines that are shown coming down are the budgets in the final 2 years of the Bush administration, showing that the budget that was provided for this activity was not what was planned. And of course, when the budget provided is not what's planned, what happens is things stretch out. And so the capabilities that were to be delivered through the Vision for Space Exploration and the Constellation program were not quite, they weren't as far along as had been originally approached. Now, outside of NASA, something amazing was happening. In 2004, this is also during the Bush administration, in 2004, Scale Composites won the Ansari X Prize. They flew their vehicle up to the altitude of space with crew and recovered that vehicle. They did it twice in a week. And in doing so, I believe they ushered in what we now will call the era of commercial spaceflight. Now, don't get me wrong, people had been talking about commercial spaceflight for a long time. I remember reading about it when I was in high school and in college. And certainly when I began work at NASA in the late 80s and early 90s, there were all kinds of proponents of commercial spaceflight. But we didn't have a vehicle. We didn't have a feasibility proof. Now, admittedly, this vehicle was not going to orbit, right? This is a suborbital flight. But still, to me, it was a watershed moment in space, these flights. And the scale composite team that performed these flights, I mean, you know, they're heroes, as far as I'm concerned. So this is the backdrop that existed when the Obama administration took over. The Constellation program, which was a slimmed-down version of the Vision for Space Exploration, was behind schedule. And the commercial spaceflight activities that, to be honest with you, were started in the Bush administration, had a feasibility proof that they could exist. The Obama administration, as it was getting started, commissioned a blue ribbon panel led by Norm Augustine to review human spaceflight, to figure out, to assess where we were, figure out if any changes needed to be made. And the Augustine Committee produced a report that, among other things, was fed into the early stages of the Obama White House as they laid their plans out for NASA. Now, I'm one who believes that you never know exactly what's in somebody's heart except for when they first speak. When they first speak, particularly, by the way, in Washington, when someone first speaks in Washington, they're speaking from their heart. And what happens over time is they make compromise after compromise after compromise, and they start speaking about the plan that everyone has come up with. And so to me, one of the most impressive things was the Obama administration's 2011 budget. And I don't want to get into the details. I don't want to be a policy wonk here and get into the details of budget. But let me just say that the 2011 budget, which was the Obama administration's first budget, was based in part on the Augustine Committee report. And that budget, which I have illustrated in the table here, if you can read it, increased NASA's budget by $500 million in FY11 and by $6 billion over 5 years. The average NASA budget in that 5-year period was $20 billion a year. Think about that for a minute. Think about how much NASA could accomplish if it had a budget, on average, of $20 billion a year. For those of you that don't know, NASA's budget now is a little over $17.5 billion a year. Okay. In 2010, NASA's budget, prior to this, was $18.7 billion. So this was an increase. Why did the Obama administration choose to propose an increased budget for NASA? Well, if you look at what they didn't actually just propose an increase for NASA. They proposed an increase for all the science and technology agencies in their 2011 budget. It was part of their national strategy. That administration in 2011 believed that investing in our future meant investing in science, meant investing in engineering, meant investing in technology, that would create the jobs for the 21st century, that was the right thing for the federal government. That was the place the federal government was going to make investments. And I'll tell you, as someone who started work back at NASA headquarters on February 1st of 2010, the day this budget came out, I'll tell you, I was thrilled that NASA was part of this major national initiative. Here, the Obama administration was going to invest in science and technology, by the way, much like Kennedy did when he created the Apollo program, right? That program was not really about sprinting to the moon. That program was about building technological leadership. And that's what the Obama administration was doing here. They increased funds for science. They increased funds for aeronautics. They put more money into human spaceflight. They put money in across the board. Now, as you know, they also canceled the Constellation program. And they stayed true to President Bush's plan to cancel the shuttle in 2010. As it worked out, the shuttle program went forward through part of 2011. but they pretty much carried forward that part of President Bush's plan. So, I was excited about this plan, and there were a number of people that were, but as you know, there were many that were not. The aerospace community in general, took this plan and reacted with a big thud. Congress was similarly not prepared. Now, certainly a lot of the blame for that, in my view, would fall to the Obama administration. The way they rolled out this plan was not smooth. But the plan itself represented a fundamental change, a big change for human spaceflight. And frankly, I think our community, the aerospace community, was just not ready for that change. It was too big of a change to take at once, particularly in the face of the shuttle program that was rolling down. The Obama administration did, by the way, fund not just 5, but 6 flights, the 6 final flights of the Space Shuttle program. They fully funded those. And they also extended the life of the International Space Station from 2015 through at least 2020 in this budget. So there was actually a lot of good news. But if you were reading the newspaper when this budget came out, I think probably all you heard about was the bad news. The plan was met with a lot of opposition in Congress. There was a great deal of debate. That debate went on for many months. And then it was rolled out in February of 2010. In October of 2010, the president signed the NASA Authorization Act of 2010 that took this budget and added in the heavy lift launch vehicle, the Space Launch System, and the Orion crew capsule, reducing funding, by the way, relative at least to the request, for some of the technology capabilities and for the commercial crew program. And that compromise was enacted into law when the president signed the Authorization Act, and that has pretty much set our plan since then. Now look at the budget, though. Although the president signed that compromise, the NASA Authorization Act of 2010 into law, when Congress got around to appropriating the funds, they didn't appropriate $19 billion for NASA. And a year later, by the way, in 2012, when the president came out with his 2012 request, he didn't stick to this plan either. He cut it back basically over 5 years to the 2010 level. So that $6 billion increase that was there in 2011, by 2012, it was gone. And then in 2012, Congress didn't fully appropriate what the president requested again, so NASA got a little bit less. Basically, the lesson here for the community is that we stand united or we fall. Because when there's a fight, when there's disagreement, it gives others, people outside of aerospace, it gives them a chance to step in and say, well, why are you funding NASA at all? Shouldn't we spend more money on Department of Energy or over at NIH or at the NSF or what have you? And in my view, whether you're for this plan or against it, this was an opportunity that we all missed. Okay, but so how are we moving forward? NASA's actually moving forward fairly well, and they're doing so in a number of areas. Of course, NASA flew out the shuttle program successfully. And I want to take a moment and tell you that in my 2 years at NASA, there were 6 space shuttle flights. I went to every one of them. I went down for several days. I met with the people that were working on the program. And I'll tell you, there are no better people in this world than the engineers that committed their lives to the space shuttle program, particularly in this time period, when they knew the program had an end, when they knew that after that July 2011 flight, many of them were going to be out of jobs. The dedication that I saw in these people's faces in their work, to fly out, this is an experimental vehicle, this is a very dangerous proposition, to fly that system out without any incident whatsoever, pretty much on schedule, to complete assembly of the International Space Station, so that we can now utilize that laboratory as we go forward in space. It's really remarkable what the people in Florida and elsewhere in the country were able to accomplish. one of my, I can't think about the space shuttle program without actually choking up a little bit. And I'm thrilled that tomorrow morning you're going to get to hear from Bob Cabana, the Center Director at the Kennedy Space Center and a former astronaut. I'll probably talk to you more about that. So first of all, the space shuttle program was flown out successfully. A sixth flight was added, and the shuttle program flew through 2011. Second, the International Space Station was completed, and funding was added to the budget to extend its life through at least 2020. The space station is now the centerpiece of human exploration. Don't think that human spaceflight is dead. It's not. Human spaceflight is alive and well. Just because you can't see the shuttle launching from Florida doesn't mean there's not human spaceflight. It's orbiting overhead. For more than a dozen years now, the space station has been permanently inhabited. Think about that. I mean, it boggles my mind to think that there have been people in space continuously for a dozen years now. Not the same people, obviously. But just that it's been permanently manned for that long a period. We live in a great period of time when that can be true. Right? In addition, commercial spaceflight has moved forward. Cargo in particular. The Dragon spacecraft, as you know, it made its second flight to the International Space Station and returned cargo in the second flight just recently. And NASA has been focused on the capabilities required for us to become deep space explorers. The Space Launch System, the Orion Crew Vehicle, and a whole host of technologies that are required for us to live and work safely in deep space. This is the plan that NASA's been working largely since October of 2010. So that's a little bit of background. And now I want to kind of look forward with you into where I think we're headed just over these next few years and where I think we're headed really over decades. Let's start with the International Space Station. I mentioned it already, but the space station is truly an engineering marvel. It may be the largest and most complex engineering undertaking ever done, and it was, of course, done through an international partnership, right? So there are a large number of countries involved in the construction and now in the utilization of the space station. As far as I'm concerned, the space station is a very important piece in our plan for human exploration. It's where we will learn to be deep space explorers. It's where we will learn about microgravity. It's where we will prove out the technologies required for deep space exploration. It's where we will understand the long-term human adaptation to space. Through technology experiments and science experiments, I think the true value of the space station is ahead of us. Many people have judged the space station to date. Personally, I think that's been a little unfair. It's kind of hard to judge a laboratory when you're still constructing it. If I was building a laboratory at Georgia Tech, it'd be hard for me to show you the benefits of that laboratory when there's construction workers running around and dirt all over the place and stuff like that. But now the station is fully assembled and it's able to carry its full crew. I think you're going to see more and more benefit from the station over this next decade. Commercial spaceflight. I've mentioned this. It was part of the first speaker's comments as well. I believe commercial spaceflight is here to stay. First cargo and then crew. I think a number of companies will take over that market of taking things up and down, if you will, from the ground to low Earth orbit. In addition, I personally am just enthralled with the idea of suborbital spaceflight. I believe, without a doubt, that in the next 5 years, there will be more people experiencing space through suborbital spaceflight than there have been in the last 50 years. That's something that's going to happen while you're either still in school or perhaps in the first few years of your career. Think about that change. Think about what it means, not just to our country, but to the world, when there aren't just a few hundred people that can say they've been in space, but there are thousands and thousands of people that have experienced spaceflight. Of course, the idea of cargo going up and down and crew, I think, is going all the way into orbit and back is extremely important as well. I think this idea of commercial spaceflight that was initiated really in the Bush administration, but accelerated by the Obama administration, I think it's here to stay. One of the reasons that it's here to stay is because it allows NASA to focus on what it takes to become deep space explorers. NASA can stop being a trucking service up and down to low Earth orbit, which is really what the space shuttle was, and can focus on the capabilities needed to go further, to go to the moon, to go beyond the moon, to an asteroid, to one day go to Mars. And here I'm not just talking about the Space Launch System or the Orion capsule. I'm talking about all the other capabilities that are needed to live and work in space safely. I'm talking about all the fuel that has to be handled and transported and stored in space. I'm talking about large habitats that have to be built, not just little capsules. I'm talking about radiation protection, in-space propulsion, surface power, all of the technologies needed for us to explore other worlds. That's what NASA should be focused on in human spaceflight, and I'm glad that they are. NASA, of course, is focused on Orion. If you were to go to almost any NASA center today, given it depends on what day you get there, but you'd find all kinds of testing taking place. Orion is more than a paper study. It's real hardware. It's moving through the test process. There's going to be space flights of the deep space capsule soon. It's really moving forward quickly. NASA is more than human spaceflight. Of course, NASA also does a great deal in science, and I could talk to you about astrophysics or earth science, but what I want to talk to you about really is the most recent science triumph, which was the landing of Curiosity back in August of this year. This is a capability, as I mentioned earlier, that had to be invented to go from landing something that was Sojourner size or Spirit and Opportunity size to landing a small car. It took a lot of work. It took a lot of innovation. It took a lot of dedicated engineering and science know-how. And of course, it enthralled the world. How many of you know where you were when Curiosity landed? Raise your hands. Everybody does, actually. I mean, almost everybody that I meet can tell me exactly where they were when Curiosity landed. That mission is that significant, I think, in our national conscience. And of course, Curiosity is just one example. In the future, I think that we will be sending missions not just to Mars, but to Titan, to Europa, perhaps to Venus. There are a whole host of secrets that we can learn from studying the planets. We learn about the planets themselves. We learn about the possibility of life. But we also really learn about ourselves in doing this. We learn a lot about the Earth. And we, of course, push our technological capabilities. NASA is also investing heavily right now in research and technology for the future, for its future science missions, for its future exploration missions, for its future aeronautic missions. And in doing so, NASA is building the technological capabilities of this country. NASA is creating high-tech jobs, and NASA is engaging folks at universities and small businesses and at the national labs all across the country in these technological developments. These are all capabilities that NASA needs for its future missions. All the way on the, I gotta see which way I'm standing. All the way on your right at the bottom there is the Irving sounding rocket flight that took place in July of this past year. The Irving sounding rocket out of Wallops Island. If you don't know about Irving, it's a inflatable reentry vehicle. So, our current reentry vehicles are limited by the launch shroud to be a certain diameter. An inflatable system can be much, much larger, perhaps 10 times larger than the launch shroud. This is a technology that we need if we're going to send humans to the planets, just as one example. And this technology was proven through a pretty low-cost sounding rocket flight. These things are happening all over the place now, and they're happening at a pretty rapid pace. These technological projects, and they're really something to behold. NASA is also focused not just on its own projects, but on innovation across the nation. These images here are from the Green Flight Challenge. It's just one of many challenges that NASA has hosted over the last few years. The Green Flight Challenge set a goal of 200 passenger miles per gallon, an aircraft that could deliver 200 passenger miles per gallon. They held the competition out in California, and both the first and second place entrants nearly doubled that goal. They nearly got 400 passenger miles per gallon. 10 years from now, I think that what we're going to say is that the Green Flight Challenge was key to the birth of the electric flight industry. I think that you'll see electric flight, and this will be one of the reasons why. Of course, NASA also does an awful lot in education, an awful lot with university students, whether those university students are inspired into educational and career paths by what NASA's doing, or whether they're involved hands-on in some of NASA's projects. This is a big push for the agency. And those of you that haven't done a summer internship or a co-op kind of assignment at NASA, I would really urge you to consider that. It's a great place for you to get hands-on engineering experience. Any of the 10 NASA centers, it doesn't, don't go to headquarters, but any of the field centers where you can actually get your hands dirty and get involved in a real project, I mean, it's just totally awesome, and I'd really encourage it. In fact, of all the things that I was involved in when I was at NASA headquarters, rolling out a whole new set of technology programs for the agency, by far, the thing that I'm most proud of is the thing that cost the least amount of money. And that was the creation of the NASA Space Technology Research Fellowship Program. This is a program that is sending, at this point it's about 128, but over time it'll be maybe as many as 500. We'll engage as many as 500 graduate students across our nation's universities in NASA-sponsored projects. So the research that you do, perhaps as part of your master's or as part of your PhD degree, it'll be, that research will contribute to those academic milestones, but that research will be sponsored by NASA. So in addition to having a faculty advisor, you'll have a professional advisor, let's say from one of the NASA centers, and that advisor or mentor will keep you aligned, keep your research aligned with NASA's interests. Obviously, there's a big benefit there to NASA because that research is directly applicable to their future missions. There's also a benefit to NASA in terms of human capital, right? There's more and more young people pouring into the agency. What better way than to start training them while they're in graduate school on some of NASA's missions? You can see that there have been awards made all across the country. There are actually fellows in all of the states at this point. It's just in its second year, but this is a program that's growing, and I'm not in charge of it by any means anymore, but it is something that I am pretty excited about. So the theme for your conference here is crossroads, and I don't really think of NASA as being at a crossroads. Actually, I think of it as a fork. I think we're at a fork, and we collectively need to decide where we're headed on this, when we look at this fork. There we are. There are two paths in front of us. One of those paths is to keep trying to do business the way we always have in aerospace. Large government programs, very focused goals, largely dominated by the government, kind of sprinting to that goal without any thought of why we're doing that, why that goal is important. It's the goal. We're told that's the goal. Let's just get there and get it. And we're engineers. Let's just make that goal happen. Let's use our existing capabilities. Let's evolve the systems that we have in hand to achieve that goal. It's a very engineering mindset. It's a very realistic, very practical mindset. The technical risk there is probably quite low, but the cost risk is extremely high. And it's that cost risk that we in the aerospace community keep running into. It's why we start these programs, and then after a few years, they fade away. It's because of that cost risk. So what's the other direction? What's that other path? Well, it requires that we take a little more technical risk. It requires that we partner, that we find ways to partner, whether that be international partnerships, whether that be partnerships across government, maybe NASA, the DOE, NASA and the Air Force, what have you. It requires that we build new capabilities so that we're not going after these missions the same way that we always have, right? It requires a little bit of innovation. It requires creativity. There is risk there, don't get me wrong. There is definitely technical risk. But in my view, that's the sustainable cost path. That's the path that I believe we have to be on. And the reason that I believe there's a fork in the road is because NASA, in my view, is kind of facing this dilemma. It's a dilemma that has faced many other industries in this nation. It's many other sectors of our economy. And it's facing the aerospace sector right now. You all are fortunate that you live in a time where you're going to get to help make this decision. The decision's not going to be answered. We're not going to answer this question today or tomorrow. But in the next few years, we're going to end up moving down one of these paths. I sure hope it's the path of innovation. I sure hope it's the path of creativity. I sure hope it's the path of developing new capabilities and new approaches to do these missions. I think that it will be, but there's a bit of a cultural battle going on now within our community about this exact direction and which way we should head. Why is it so important to take that path of new capability, new innovations, new creativities? Well, think about the way we have explored, and then think about that Mars example, for instance, that I showed you. Do you think that we can take the Apollo mindset and actually sprint to Mars and back? And if you do, what do you think is going to happen after we plant that flag on Mars? What if we build the infrastructure to go to the moon sustainably, or to go to Mars sustainably? What if we build the capabilities, the technologies, to do it a different way? I think there are a whole host of new ways to accomplish these missions. In doing so, we'll build the technological capability of our nation. In doing so, we'll create the jobs of the future. And in doing so, we'll accomplish our future missions in exploration, our future missions in science. Think about a future space telescope. That space telescope may or may not look like the James Webb Space Telescope, which is all the way on the right in this image. Maybe that space telescope consists of formation flight of a whole bunch of smaller telescopes. Maybe it consists of some inflatable or deployable membrane that forms the basis for the optics. Right? There are a lot of different ways to skin this cat. Right? It's not always the same approach. These technologies will allow us new approaches for exploration, new approaches for science. We'll utilize the International Space Station as a proving ground to demonstrate these capabilities. And of course, in doing so, we won't just accomplish NASA's missions, but we'll help improve society here on the Earth. Right? Think about the Chilean miner disaster and how space technology and the biomedical expertise that was gleaned from spaceflight was applied there to save those miners. The Gulf oil spill, NASA was immediately called on to assist in that cleanup effort. The recent hurricane that hit New Jersey and New York, right? Our remote sensing capabilities are very important to the Earth. But so are the investments that we make in technology, because they spin off in a whole host of ways. You may not really think about it, but space is all around you. How many of you used GPS today in getting to this conference? How many of you checked out the weather in Buffalo because you were worried about snow? I mean, I did. The Weather Channel. Right? Do you know that when I was in Washington, a particular congressman told me that he thought that we could cut the remote sensing budget of NASA because we didn't need any more weather satellites. And when I asked him why, he said, well, it's because we have the Weather Channel. Well, I explained to him that someone has to give the data to the Weather Channel. But it's not just those big things like weather and GPS, right? It's baby formula. It's actually clotheslines that come from the space program. It's biomedical applications like the valves in artificial hearts, pacemakers, LASIK eye surgery, the protective armor that our police, firefighters, and military wear. All of this came from spaceflight. So when we invest in space, those dollars are not spent in space. They're spent right here on the Earth. And of course, they return great value here on Earth as well. By investing in technology, we're not just solving NASA's missions. We're not just creating jobs. We're actually building a better future for us all here on the Earth. And so I want to go back to that question that I started with. What is that space race of our generation? What is that grand challenge that will serve to measure and organize the best of our collective energies and skills? I believe that it's the same today as it's always been. I believe it's about technological leadership. That's what it was about when President Kennedy said, go to the moon and return a man safely within the decade. It wasn't about going to the moon. It was about proving that the U.S. was a technological leader. It was about the economic and national security benefits that come from being a technological leader. And I think the same is true today. We invest in our space program because it inspires us. We invest in our space program because of the economic benefits and the national security benefits. And all of those things come together around technology and capabilities development. Thank you very much for your attention. If we have a little time, I'll take any questions you might have.
We do have time, so we have a microphone up here and also a microphone that we can bring around. So anyone who would like to ask questions, put your hand up or feel free to come up.
Sure. Hi, my name is John. I'm also a graduate of the University of Buffalo here. Can you comment on the technological maturity of the cryo-boil-off problem that you had cited in the fuel depot? And if you also have any insight into soon-to-be-announced White House human spaceflight policy?
Soon to be announced, like it's a fact. All right, so first let's talk about cryo propellant storage and transfer. There are a number of technologies that are in development today that have been in development for the last few years that are showing great promise for cryogenic boil-off. There are, people have the goal of zero boil-off. I don't know that, to be honest with you, I don't know that we'll ever get to zero boil-off technologies. But I do know from doing systems analysis that this is a huge swinger for any deep space exploration mission. It doesn't matter where you're going to Mars or whether you're going to an asteroid. Those are long duration missions. It doesn't matter whether you want to, if you want to have a habitat of some kind near the moon, for example, for a long duration period, it takes a lot of propellant. You need to keep that propellant safe. And so I think this is an obvious area for investment. If you look back a lot at the reports that have been done, this is an area that NASA has known it needed to invest in for many decades. And I will tell you that prior to 2010, there was almost no investment taking place. Okay? So this is an area that we have chosen to invest in, and personally, I think it's the right one. The work is largely being led out of the Glenn Research Center and at the Marshall Space Flight Center. But it involves a number of universities and small businesses as well. And that work is proceeding fine, proceeding along just fine. In terms of the second part of your question, I don't have an answer. Because I'm not affiliated with the administration at this time, and I know about as much about that as what I read in the newspaper. So I don't really want to speculate. Sure. I can repeat it, maybe.
Thank you. Dr. Braun, Frank Liu from Arizona State. A couple questions. First, I agree with you, we need a new space race to kick off public support and congressional support for NASA especially. However, why isn't our new space race versus other space agencies from other countries? Like China's very strong in this field right now. They've sent up astronauts, and yet they've been barred from the ISS because of the United States. Wouldn't international cooperation be better than trying to hinder other institutions? Also, wouldn't fear-mongering among politicians improve NASA's support? I mean, if you consider it, the only reason we went to the moon was because we were afraid of the Russians. If we garner the same support against China, we may make it to Mars, since they have a 2030 deadline for their Mars colonization.
Yeah, so a couple things. I don't believe that the only reason we went to the moon was because we were afraid of the Russians. I just want to clarify that remark. So we went to the moon to show the world what this country, what a free nation could do. So it wasn't, I mean, yes, people were freaked out about Sputnik, but it wasn't totally, we're scared, what are we going to do? It was more of, we're going to show the way. It was more of a, we're going to be a leader. And in fact, that's one of the things that I think that the space program, one of the best characteristics of the space program. The International Space Station, I would argue, is in that mold. People don't think about it that way, but you may or may not know this, but in the 90s, the International Space Station was one vote away, a single vote, not a single person vote away from being canceled. Right? And and I think about the International Space Station, I think about that partnership that was created, us and the Europeans and the Russians, who were once our adversaries. In completing that, I think not only is it a remarkable engineering achievement, it's a remarkable geopolitical achievement. And when I think about how well we partner in space, sometimes I wonder about why don't we partner that well just here on the Earth, right? So it's a great example of how we should lead our lives and how we should live in the world. In terms of China and India and some of the up-and-coming space powers, I think that they'll all eventually be part of this, just when the time is right. I don't know when that time will be. I don't believe that the U.S. will do any of these great deep space exploration missions that I've been talking about by itself. I think we will. These missions are too big. We're going to go to Mars as a world. We're going to go to an asteroid as a world. We're not going to go as the United States of America. When we get a little closer to actually doing that, we'll see who the right partners are. I think it'll depend a lot on the state of politics across the world at that time. But I wouldn't rule anything out today. I hesitate. I almost took the word space race out of my slides. I don't really like to call it a race because it implies a competition with other countries. And I don't think of it that way. I think of it as a race because a race is something that excites America, right? Everybody loves a race. Everyone wants to go see NASCAR, right? Even especially if you live like I do in the South, right? You want to go see NASCAR race. But it is a race for technological capability because technological capability affects so many other things. It affects our economic future. It affects our national security future. It affects jobs across this country. It affects our standing in the world. And so, in a way, it is a race for technological leadership, but it's a race that we're going to accomplish, I think, in the end, that we will accomplish as a world. Is that making any sense? Okay. Thank you.
Good evening, Dr. Braun. My name is Sean McGrath. I'm an alumni of Cornell University over in Ithaca. My question is, so I remember growing up during the mid-90s or so, and over the course of that time frame, I remember always hearing that we were going to have a man back on the moon by 2000, and we were going to have a man on Mars by 2005. And it always seemed like these big jumps were just over the horizon. And right now in your talk, they all seem just over the horizon again, even though earlier in your career you were working on a manned mission to Mars that hasn't happened yet. So what would you say is the big difference between now and, say, 15, 20 years ago in our outlook towards new developments happening in our exploration of space?
Yeah, that's a great question. And that's actually one that I think about a lot. So just to give you a time sense, when I worked on President George H.W. Bush's space exploration initiative, it was the late 80s. And yeah, we were talking about humans to Mars in the 2000s. I've also, by the way, in the robotic program, right? Right after Mars Pathfinder, I worked on Mars Polar Lander, which failed. But after Mars Polar Lander, I worked on the Mars Sample Return mission that was going to land on Mars, gather samples, and return them, I think, by 2008. So it's not just human spaceflight, by the way, right? So anytime you set a big goal, if you don't get the funding to accomplish that goal, it doesn't go your way. So I guess the way I would answer your question is there's two ways to approach these things. In the Space Exploration Initiative, George H.W. Bush's Space Exploration Initiative, within a year or so, that was pretty much dead. And it was pretty much dead because it required what was considered at that time to be a very large budget infusion that wasn't coming. Right? There are other examples of that as well. The vision for space exploration, when it was rolled out, there was a budget infusion that was supposed to be a part of that, which didn't materialize. So I'm not one who believes that what we should do is continue to talk about these things if they require a big budget infusion. Instead, I believe that we should develop the capabilities to accomplish these missions before we start selling them with dates and destinations. Right? The problem is that the press, they always want, and Congress, and others, they always want to know, what's the destination? What's the destination? And they want that date to be, 4 years from now. Well, these things are pretty complicated. And if you want to do it, by the way, we could do it within a decade, like they did in the Apollo days. But that's going to require a huge infusion in budget. Right? Back in the Apollo program, the Apollo program peaked at about 4.5% of our GDP. I'm sorry, 4.5% of the federal budget at the time. Today, NASA gets less than 0.5% of the federal budget. So, are you going to take an order of magnitude, roughly, increase in NASA budget to get that done in a short amount of time? Probably not. So, given that, my view is that we should focus on the capabilities that we need to become deep space explorers. We know what those building block capabilities are, right? I mean, they've been documented in study after study after study. If you compare the 15 studies that have been done on deep space exploration from 1968 till now, and I can give you those studies if you'd like to see them, but if you compare them, they will list about 15 different technologies, and almost about 12 of those 15 technologies are in every study. I mean, it's a consensus that you have to make an investment in advanced propulsion, or in cryogenic boil-off capability, or in aero capture, some of these kinds of things. To get that capability is going to take an investment of time and an investment of resources. So what I believe we should be doing is making those investments now, and then a few years from now, set off on a very crisp and clear dates and destination approach. But I don't believe that time is today. Thank you. Thank you.
Hi there, John Stark from University of Colorado. One of the key points you touched upon was sustainability moving forward, that, the cornerstone of what you want to see is, not just go someplace once and then have stagnation for, the next few decades. And, you also mentioned, we're the ones who are going to be making this decision. We're the ones who are going to be steering our country down one of these two roads. I guess, how do we best steer this? Do you have any words of advice in terms of, how do we take it out of the sway of public opinion and to make it something that we can actually keep going on, that we can keep the ball rolling on a project instead of skipping from one to another to another to another.
Well, so a really good friend of mine told me once that life's a journey, enjoy the ride. And, if you're someone that's all about the outcome, you're not going to survive in this business, right? But if you're someone who knows, over the course of your career, what you want to accomplish, you'll get there. You will. You have to stay true to your passion. You have to stay focused on your goals, and you will make it happen. I've seen it. I've seen it time and time again. I know people that worked in this business that are, since retired, that they accomplished everything they wanted to accomplish. Now, it didn't come to them on the time scale that they wanted it. They wanted it in 5 years, and it took 15, right? In my case, I'll tell you, I joined NASA because I wanted to land something on Mars. I did that before I was 30. I was very fortunate to be a part of the Mars Pathfinder team. It just worked out that way for me. And then I had other goals, and I still have yet to achieve them. I showed you some of those goals today. So there's a couple ways that you can do that. One is to stay focused on your goal. There's going to be a lot of noise, for lack of a better word. There's going to be a lot of noise in the system. There's going to be a lot of, he said, she said, reports in the press, and there's going to be, this administration and that administration. But if you're committed to your goal, whatever that goal is in aerospace, I believe that this is a world and this is a country where you can make that happen. And so that's first. The second thing I would say is, and it's been said already tonight, is get involved. Engineers tend to think that it's all technical, and if they sit back in their room and they work at night, they sharpen their pencils and they do their calculations and they stay in the computer with the shades drawn, they don't talk to anybody. They get the right answer, and everyone's going to say, hey, that's great. Well, it doesn't work that way. If you get the best answer in the world on some new capability, but you're not communicating that capability to others, it's not going to advance. Part of your career has to be external. And it's very hard for engineers to do this because most engineers are introverted, right? Most engineers are not seeking the limelight. Engineers, generally speaking, they want to change the world, but they're focused on technically how to change the world, not on how to communicate that change in the world. And we need more people. We need more engineers to actually communicate their visions of the future. And then lastly, what I would say is you will find people in your passion, in your direction, that you bond with. You'll find people that have the same vision that you have. You might not know them today, but I'm telling you, you will find them. And when you do, stay in touch with those people. Work well with those people. Don't fight with those people. When you have people that are aligned, but they seek the limelight and they fight, they both lose. Right? In my opinion, that's what happened in the 2011 budget debacle. And that's true. I've seen that in a lot of technical things as well. So anyway, stay true to your passion, build your team, and communicate. That's how you'll be successful.
Excellent. Thank you, sir.
Thank you.
Okay. Oh, wow, that's on. Sorry. Unfortunately, we are out of time tonight, so I would like to thank Dr. Braun for coming.
Thank you all for being here. I really appreciate it. It's great to see so many young people. In particular, it's great to see so many folks interested in space. What I'd like to do today is talk to you a little bit about my vision for the future. And I want to emphasize as I get started that this is really my personal vision. I am an employee of Georgia Tech at this point. I no longer work for NASA. But my views have obviously been shaped by my experiences. My experiences as a technical person, as an engineer that sent probes to Mars, and most recently as the chief technologist for NASA. I want to talk to you about the future, but I thought that to talk about the future, we should probably start at the beginning. We should probably base our discussion in the past and in the present. So I'm going to start where most people start when they talk about NASA. It was more than 50 years ago that a young president spoke to the nation and gave this nation a challenge that was not simple, a challenge for which we didn't have an answer, a challenge that was audacious. And of course, you know the challenge that I'm speaking of, the challenge of sending a human to the moon and returning him safely to the Earth within a decade. Upon hearing that challenge, thousands of young people, thousands of engineers, thousands of scientists poured out of the nation's universities and joined NASA. They accomplished the president's goal. Look at them here in some of these pictures. Look at how young they are. You may not know this, but when
the students of today can learn from the professionals out there, their skills, and those skills can help build a better tomorrow. Get involved because you make the difference, not only to those right around us, but nationally. We can affect policy, the national focus of the future, and go forward to a better tomorrow. We can set the future and take us to the next frontier. I'll now turn the floor over to the conference manager for SpaceVision 2012, Mr. Andrew Gianetti.
Thank you, Dan. On behalf of all of the SEDS team, I'd like to welcome you to Buffalo and to SpaceVision 2012. We're excited to be your conference hosts, and if there's anything that we can do to make your experience better, please feel free to contact one of our staff. Since its modern inception 8 years ago, this conference has grown to be the premier gathering for students and young professionals seeking to become involved in the space industry. We're brought together by our common passion for space, the desire to explore further than ever dreamed possible, the drive to learn about the universe around us, and the dedication to face and overcome challenges that quite literally can be astronomical. Over the next 4 days, we hope to harness this passion and motivation and explore and define how this generation can impact our future in space. We seek to explore the theme Crossroads. With the space industry currently at a turning point, undergoing significant changes in the way we access space, we believe that the future of space exploration and development will hinge on the activities of the coming years. As we find
Over the past few years, SEDS has seen a great expansion. We're this year at record numbers for our overall college chapter enrollment, and I cannot wait to see what the future will bring to the organization. It's not to say that we've grown larger through one event or one particular focus or another, but through our overall dedication as students to our shared goal. It is sometimes said that it takes a village, and that can be said exactly for students for the exploration and development space. It takes the students among all of us to make the organization work. If I was to say one thing about overall, what I would encourage all students to do is get involved. Get involved, because without students, there is no SEDS. There is no SpaceVision. And our mission of getting to space to explore and develop the future is at risk. Get involved, because even the least effect that you've done, that you can do for anything related to SEDS, can make the greatest difference. Get involved. You make what SEDS is. Start initiatives in whatever you think is going to make the future happen. Ask for help. Only take no as a temporary setback and not a roadblock. Make it a challenge to overcome. Make the organization what you want it to be. Join us today, be a staff member, and make a difference at a national level. To the professionals joining us this evening, I still say get involved. Your help makes it so students can do so much more than they're ever able to accomplish on their own.
Neil Armstrong landed on the moon and walked around. The average age of a person in mission control was 29. Think about that for a minute. 29 years old. President Kennedy's goal was audacious. It was a grand challenge. Upon hearing that goal, engineers built some of the most powerful engines ever constructed. They built rockets more than 36 stories tall, and they sent brave heroes on a journey farther than they'd ever been, and in fact, farther than we've ever been yet, since that time. By fusing the creativity and imagination of their time into technological solutions, these engineers and scientists captured the imagination of the world. When Neil Armstrong took that one step, we all took a giant leap. And in doing so, they defined what we now call rocket science. Many of you out here probably want to be rocket scientists. If you listen to Jay Leno or David Letterman, they make little rocket scientist jokes. Well, before these folks, nobody knew what rocket science was. They truly changed the world. And in doing so, they had a lasting impact upon our national security, upon our economic security, and upon the United States' leadership, technological leadership in the world. We didn't go to the moon to explore. We didn't go to the moon just because it was in the human spirit to do so. President Kennedy sent us to the moon for a reason, and it's best described.
We find ourselves at this crossroads. We believe that our generation will be vital to shaping the industry in our future. Through this conference, we will explore the areas of science, engineering, entrepreneurship, and policy that shape the industry and will be important to our future. We believe that our future is in space, and that it is up to us to reach higher than we ever have before. This conference will create a setting where students can build and strengthen connections with industry professionals and leaders, and learn about and discuss the topics that are relevant to our future. I would now like to take a moment to introduce our opening keynote, Dr. Robert Braun. He will be speaking about the role of NASA in the 21st century, a topic that is very, very relevant to our future. Dr. Braun is the David and Andrew Lewis Professor of Space Technology at the Georgia Institute of Technology, and previously he worked as the NASA Chief Technologist, where he worked to develop cutting-edge technologies to enable future exploration. Without further ado, Dr. Braun.
I'll try from here. How are you this evening?
Good.